We are going to get started. Our next speaker is Aspi. Aspi is Director of Engineering at Google, leading infrastructure software development in the areas of mobile and application serving, software-defined networking, messaging, microservices architecture. Aspi has worked at various startups and established networking companies before coming to Google, such as Netsys and Cisco Systems. I'll hand over to Aspi.
Thanks. Thanks, Deepak. Hello, everyone. So, actually, very nice. Thanks to Microsoft for arranging this meetup. I guess this probably ends up becoming just like Facebook does the at scale. A lot of times we are all busy in our work with lots of stuff to do, and you're tempted to kind of say, no, I don't think I have time. I'll do it next time, So I decided this time I should force myself to participate in these things because otherwise life anyway never changes. And I was thinking what to talk about. I started at Google for the cloud networking to work on it as a direct responsibility around 5 to 6 years back. Cloud was doing its stuff separately before that. And we were all part of systems infrastructure, which means we were developing software for Google. Where is Najam? Just the wonderful life that he is living right now, right? So, and I said it'd be good to kind of reflect on what it's been like to kind of shift our responsibility. Technically, technically it kind of looks the same, but just to be able to be in the cloud business, how everything has changed, and what challenges came out. And there's so many experienced people in the audience here, so where you have probably seen similar effect in your own space, and I'm very curious as we get suggestions and ideas on how certain things could be solved. So let's go through that. This is just a general diagram of our cloud footprint, which is probably a little smaller than actually much smaller than the overall Google footprint, but cloud has pretty much caught up with all of the Google's broad footprint. When I was in the regular systems infrastructure, we used to say, not to worry about the cloud workload on the network. And if it becomes a problem, it'll be a good problem to have, okay? Because Google Cloud was still pretty small. Last few years, it has become a massive problem. And I don't know if I can still say it's a good problem to have, okay? So now let's go through all the different thought process, change in work style, change in responsibility, and all that we have gone through for the cloud journey. So here we start. We said, what was the promised vision? I was thinking. When people came into cloud, I think we promised a lot of things to the users coming on, right? Honestly, we cannot say we have really fulfilled all of them, but it's good at least to reflect back on what we need to achieve, right? So quick bootstrap definitely is an achieved thing, right? A user can very easily come on, right, into the cloud and fire up a bunch of VMs, fire up a workload, get off it, and that's all they pay for and nothing else. So that's a great gain for the user. Similarly, they can think they can get capacity on demand. Now, this should come with a little bit of caveat because it depends upon how much capacity on demand, right? Like the other day, just earlier this week or end of last week, my storage team lead said, yeah, we did this storage stuff. This was supposed to be cold store, meaning like, you generally put it there, but you're not supposed to use it, right? Once in a rare while maybe. But now our users have started really using it like on demand. There is a government request for something. They want to pull all the data over the last 6 months and pull some stuff out of it and report it back to them. So actually it's really hot storage. And so suddenly we need a few terabytes of network stuff. And I'm like, excuse me, but that's a complete shift, right? And you cannot just think I can develop the product on my own without, let's say, networking, completely being aware and somehow doing it, because you cannot build a network like that, right? Which is just sitting there completely idle, and once in a while, a few terabits just comes up, right? So I think these are the kind of challenges which are coming up, okay? Ease of use. This is, I would say, at least, I guess we don't have too many users here, hopefully, for cloud. So ease of use, I don't think public cloud has really delivered, right? There are certain things it is easy to do, but I think our users are still struggling, to learn a new stuff, right? Freedom from operations burden definitely is there, though I can see the insecurity that engineers who are doing development and on cloud having lack of visibility into what is going on. So I think that we really need to provide. Even though we don't want them to toil with operational load, okay, I think it's necessary that they get visibility. Okay. Latest technology, I think that's a fair thing. That's easily provided because cloud vendors will upgrade the hardware every 2 to 3 years or even faster than that. New products and technologies come up and cloud users just get it straight. Managed services, this is the one thing I feel that clearly users want managed services. Even when we say, let's just support all these open source services and all we need to be able to do is make sure that people can use them on the cloud, that's not really what they want. I think they always want to say, yeah, it's good that you're supporting this open source service, but I would like you to manage it yourself, right? Because they think they definitely want to get out of it. Security, this was a big thing, right, at the start where users said, no. Anything which requires security, I'm not going to go on the cloud, right? People said, banks will never come on. These people will never come on. But actually, they are realizing that public cloud can be more secure than them doing the whole stuff on their on-prem. So I think security is definitely. And high reliability, this is a little funny. So I get this questions all the time from users where we'll have some outage as usual that we all would have, and we would have recovered, and then you are called in to explain to the major users why did it happen, right? And since you are aware, you are in this customer-provider relationship, so customer is always correct and you should listen, so you hopefully just quietly listen. But the way you get asked these things like, how could you have had this failure? You wonder at times, can I have a casual conversation later on as engineer to engineer and ask you, when you were running it on-prem, did it ever not fail at all? But in this situation, the business we are in, it comes with the territory, and high reliability is absolutely expected. And so this is a huge challenge for public cloud providers. Okay, so that's where we go, capacity and capacity quota, So one of the things, I'm sure Azure and AWS also has similar stuff and others too, that you want to put some quotas on all the different resources, like how many VMs, how many virtual networks, et cetera. And generally, you put the quotas in so that abusive users don't DOS you, right? Because credit card comes, dime a dozen, people get it all over, they fire up stuff, they want to generate an attack somewhere, you want to prevent that. But for reputed users, you really want to kind of say, like initially my thought was, why do we need quotas? They have a credit card, let them charge, please, I want more usage to be there. But we realized that it is not as easy as it's said to be done. And at times, we have found ourselves burdened that now from the field, you are getting this quota requests all the time, right? And I'm right now working on an initiative where it's like, I want to create some sort of a bundle which says, this is a large enough bundle that pretty much most people should be able to work under this quota bucket and never ask me about any quota approval. And hopefully, anyone who requires beyond that is a highly named, huge customer opportunity that a handful, 5 of 10 requests only come to you. Okay? This would also mean that I think you have to tell the field, as I'm thinking, that if your customer's design doesn't fit in this quota bucket I gave you, you're doing something wrong, right? For example, right? We naively have a quota which says 1,000 firewall rules. We can clearly go beyond that. Okay? Now you get a quota request from someone which says 65, 536 firewall rules are needed. You can quickly smell it. Something is wrong here. This is 16-bit. Someone's messing something up. But you have to still answer the question, right? A product manager gets it. It's escalated. Product manager looks at that number and says, I don't know what I'm talking, right? So now the dev engineer opens a ticket, and you have to answer it. So I think that's what we are thinking. This is another challenge, right? Heterogeneous workload is an obvious, huge thing we have encountered. At Google, when we did before this as systems infrastructure, we were always very confident. Of course, we scale, we do all sorts of stuff. But the big challenge I found when I came to the cloud side working on it is that at Google, most of the services were like homogeneous, right? People did things in a certain way. And when a new team came, they picked up from existing knowledge, right? And if someone did in an odd way, you would call them up and say, what are you thinking, right? You don't have that luxury with cloud users, right? So heterogeneous workloads really create a lot of challenge, okay? This is reverse. Not only do the customers sometimes don't have the visibility into the underlying infrastructure, we also do not have, at times, visibility into what they are doing, right? And so it kind of goes both ways. It's a huge challenge, okay? Oh, this one, the non-HA user workload. So this is another one where you cannot say anything to your customer, right? I could have an instance where someone, a startup, let's say, hopefully mostly a startup, has suddenly become more used, and they have a singly home database, right? Literally sitting on one mega huge VM, right? And the question asked to the public provider is, how dare you fail? When normally if it was a Google service, I would have said, who even allowed you to get on the production network? Okay. But again, this is a challenge in the cloud world that you just cannot just dismiss it. You try your best to somehow help them out with it, okay? And testing. Obviously testing is super important, we all know that, but testing is a huge challenge for mixed workloads, right? Try as you may, and whatever testing and so I'm curious in other disciplines and industries how, all of you solve this. Try as you may, and put all sorts of test cases and all. It's nothing like finally rolling out in production, right? So we have a day zero cell where we have a few users who have been given like a free ride, they can do it. We even started a concept saying canary cluster for the user, where we have invited them saying, put your example workload over here, right? So that we will know if your stuff fails, and you will also come to know if your stuff fails as we're rolling out. But users don't really pick up that much. We have started some, but that's the big challenge, about mixed workloads. And the last one is the reliability versus pace of delivery. So Najam described, right? He said, what was it? He said, operations before feature or something like that. Basically, he said, the feature will be sacrificed, or the feature goes back if I cannot reliably run it in operations, right? We used to do that exactly the same for Google. But in a commercial world where where now your PA has to have profits and loss and revenue numbers and everything else, the challenge is there. And it's not like every time I can say, let's not deliver it this year, it's okay, because I don't think it's reliable enough. So that kind of compromise you're always making, okay? Challenges, I think, what the customer faces, it's the exact same thing, They feel like I have to keep asking for capacity, quotas, and all the time. And why don't I not just have infinite as I expected, kind of stuff. The second one, I wish, and I think we should solve it someday. Otherwise, this is one huge thing that we did not deliver, is like all our users are having to get now trained in new configuration language, right? Either it's the UI side, the API, the CLI, right? I mean, it's like they are learning some new stuff. It's not what they were used to. Actually, I tell this funny story to my peers and all. When I came to cloud, I became totally responsible for cloud networking development. My first thought was, let's check what AWS CLI is and just clone it. Right? I thought it'll be a good service because all our users then will have uniform stuff. And the reason I suggested that was that when I was at several startups, and at one of the startups we were there, and we were creating a networking product to do wide area network optimization. This is exactly what we did with iOS, right? I worked at Cisco a little before that. I would open up the Cisco developer guides and all. I'll recreate the exact command. And actually, everyone was happy. Cisco was never bothered. It should not be. It served in many ways. If Cisco wanted to buy the startup, they would have no problem of conversion, right? The users were actually very happy because they would go and say, oh, wow, this is the stuff. And at times, since some of us had come from Cisco, even some of the small limitations or bugs which were there in CLI, we had fixed. So they could recognize it. But of course, I could not do this here because the lawyers immediately said, you better not even think about it, right? But I think as public, so I was talking with Deepak yesterday, and I have some thoughts, and I want to kind of talk about some things we should start standardizing, right? I think it'll be valuable for the user experience rather than having, because the reality is public cloud is here now. That's the obvious reality. Multi-cloud is a reality, okay? There is just no question about it. And for the user to go from one to the other and having to experience that is not good. Of course, we are creating a cottage industry of startups who can put the overlay on top and start saying, oh, use my stuff, But I think we could make that helpful. Lack of visibility to underlying systems, I talked about it. How to design a reliable system architecture. Yeah, I think this is something customers are actually asking us, right? Saying, give me reference architecture. Tell me how to do this, okay? But we are also all running so fast, right? No one has the time, and we are asking some field organizations or professional services group, please write, some stuff. And I think we're slowly creating the library. But that's, I think, useful. If we show that, that can help the public provider in the long run that the system architectures are more reliably designed, okay? And I guess they have the same challenge that we have as a provider, which is, should I be demanding new technology or should I be demanding stability? And how am I doing on time? Yeah. And the real question comes like this. So we had an initiative going on over the last 2 years about doing a lot of work on improving reliability. Right? And I get calls from the field, and so it came in such that it wasn't like anything comes in and it says, here are another 1,000 resources, right? You are kind of balancing. So obviously it hurts your feature development, right? And the field salespeople who know you would call in and say, I'm really disappointed, this stuff has not happened, you had promised like this and all. And you say, do you know about this whole huge thing that we are doing for this improvement of reliability? And you should be seeing some effects, and hopefully down the line, it will be even more, right? Do you even ever talk about it to your users and your customer, and the customer appreciates and says, yeah, Tom, don't worry about it. Let that feature come 2 quarters later. I'm so happy Google's got the vision to do the reliability. Generally, you don't get that answer. So this is, again, a challenge, right? And the customers, I think, cannot really make this stuff. This is the single most vulnerable thing I have found in our ability to not only deliver products fast and and ship it out. Make reliable systems. Since, as most of you should know, at Google, we have the separate organization called SRE, which does the operations, and the developers are separate. So keeping them happy that they are not totally upset and kick us out, as our product. In all of these things, testing is like the weakest point and the most important space. And of course, this is not something new. We all knew that. We have been doing it in the past also. But getting our engineering teams and everyone like totally buying into it. The one good part at Google, at least development-wise, is that we don't have a separate test group, right? Like, let's say like Cisco or networking, where I came from, there's a separate QA team, right? You have the hardware, you have the software, you have the management, and then the QA, kind of separately stuff. So we don't have that. Engineers are mostly responsible for all of their testing, but really taking this way more seriously is an absolute key thing, right? As I said, it affects pace of innovation. Automation in testing is absolutely key. And the big part of testing that I found is that it's not just writing tests, running this automated, et cetera, and all, but removing flakiness in test. Flaky tests, I think, is the biggest curse I've seen in this space. And what I've learned in that is, so when I initially used to ask and talk to even my senior engineers and all, they're like, yeah, I think we have 65%, kind of, and 35% failure, flake stuff. We reason it out, and I think we can go to 85. And I was lax about it. I did ask questions like, what do you mean? It has to be 100%. Either it fails or it passes. But I was given all sorts of explanations, and you kind of accept it and you move on, right? Having gone through that pain, realized the failure and all, I don't even have a doubt in my mind now, And it's like, no, it's 100%. It's not 98, it's not 95, it's not 99, it's 100%. And I'm personally actually working in this initiative that we have started in cloud networking, and we've been working for last 3 quarters to just remove all the ills from the past which were accumulated. I was talking with Deepak yesterday, like, we should have the opportunity sometimes to kind of start something and then say, I clean the whole slate, and I'm now going to start the whole thing again with everything that I've learned. But we never get that chance to do something like that. But flakes, I would say, if you are ever going to adopt anywhere in your systems, ask for 100% with 0% flake, and if you even let 5% creep in or 2% creep in, that system is useless. Okay? Literally, it's as severe as that. Load test. Load testing is another critical thing, and someone commented to me the other day, and I said, you're absolutely correct, and I will try to now reverse back from where we are and hopefully get to that state, and which is like, include load test in your development from the development stage. Don't expect load tests to happen later, right? So the weakest thing we can do is we develop everything, we test, let's say we do feature testing, everything and all, and then you tell someone, hey, I need a load test to be run. Just make sure it can go to scale. Total failure, okay? It needs to be from the start, okay? These are these principles that sometimes you learn in a hard way, You hope you learn quickly in your life, and so that you just say, these are invariants. I will never compromise on this, but these are some of the stuff we have had to learn as we move to cloud, And you would think like, you should have learned this long back if you have had a long tenure in industry, but you do it in certain ways, and when you fast moving pace, you kind of make a mistake. And yeah, emulation lags reality. So to do some of the scale tests, you can't really create huge infrastructure with huge networks, so you obviously do emulation, right? There's no other game, right? I cannot have 10 customer networks with 50,000 VMs each. It just doesn't become reality, and so for scaling and all. But that means that bugs creep into that, and you just have to be aware about it and figure out some other ways to take those out, okay? this is another initiative which we started, is that, so we have an instrumentation, because we do something called user space packet switching, such that we skip the host kernel and go straight through our software stack to get packets onto the NIC, and even try to skip the guest kernel and all. We can sniff every packet. We can at least look at every packet. Of course, there's a scaling part and some sampling, but we can pretty much do it. Based on that, we are able to get very good visibility about all the flows in our network, right? And developing tools from that, one of the things we have started is that every time we hear about any issue, which is always happening something or the other, the team tries to kind of reverse engineer from that and put some ML algorithms and all on it to kind of figure out so we can diagnose it, and hopefully that develops the stuff. Okay, I think this is my last slide probably. So this is I guess we don't have anyone from AWS here, right? Is there anyone from AWS? No? Okay. I guess we'll have to reach them somehow. So I did talk to Deepak, and we will explore this afterwards and see. As I said, some things, it would be nice to set up some standards and some common ways of doing stuff. Let's say, for example, VPN interconnect, right? We know it's going to be multi-cloud, right? We know people want to create, let's say, VPN, even the IPsec VPN tunnels, right? Today, and we've had to do with someone who was GCP and AWS and all, you're trying to figure that stuff out. You read the manual, they set it up. There's some things, permissions allowed, not allowed, or that VPC you can do like this and all. This should be a push button, right? And there's nothing proprietary here. Everyone knows this stuff. There's no big IP here, right? And the user experience would be amazing going on both sides. It says, I have workload on Azure, I have a workload on GCP. I would like 3 tunnels of 2 Gbps each. And we say, that's all you need to know, and everything's done deal, right? Typically, we do VPN tunnel to an on-premise, I can understand, right? So you've tried it with a few vendor devices. You tried the Cisco and the Junipers and the Palo Alto network, and some you miss, and you can do some stuff, or they configure. But here, I think we can really make it. Similarly, other stuff, right? Just like we had NetFlows and SFlow, right? We could create something like Cloudflow, right? So that the user stats, kind of come in a common way. And that means we don't have time. Other startups will come up with, business models to analyze that stuff and all. It just helps everyone. Within Google's core networking thing, they have been working on, this is the Anis and all, doing the network model and all. Same way, there are people from academia and all at Google who are interested in it. We could, talk about that. gRPC, of course, is the open source process invocation, stack that we started. This is basically something we use within Google itself. This is our next generation from the stubby, just like protobuf. There was always protobuf in open source, but invocation stack was not there. So I'm saying this is the thing I'm hoping that in these meetups and all, we can somehow take advantage of this communication and brainstorming we have, and maybe create some standards in the public cloud space. Pretty much it. Questions?
Actually.
Hi, Aspi. Thanks. So there's a lot of effort going into all of what you said. One of the problems that I've seen, and perhaps I'm curious how Google handles this, is that a lot of this automation capability is dependent on the BIOS of the systems. How do you synchronize the BIOSes of all these systems over thousands and thousands of machines? Because that's got to be outside of all the automation framework, right?
By bias, you mean that when I'm trying to do some automation, I'm assuming certain things?
Correct. That, so say, for example, there's an assumption built in on the network type or the virtualization type or what's the level of support, that you need. And so how do you synchronize the BIOS across these hundreds of thousands of servers?
So at times, as far as the different types of underneath infrastructure and hosts and all we have, that mixture we make sure. So we have a staging setup, staging network completely, or rather staging, I would say, infrastructure, just like production, right? So in every cluster where production is going on, we also have a staging cell. So effectively, whatever is the variety in the complete Google deployment, we should be able to see that in staging. It's just that the scale is different. The scale is smaller, right? Because of course, we cannot take the huge whole cluster away, right? So that's how we get the variety taken care of. It's the user workloads where we get stuck, because we cannot imagine the user workloads. And so we are guessing on that. But the underlying infrastructure is not a problem, because we are present in every cluster where cloud is deployed. So that's how we get that.
Thanks for the great talk. Could you elaborate more on what you had in mind for a network model?
So what some of our engineers and researchers have done is that where Google deploys all the way from fiber up to the, let's say, L3, L4 level, right? It's kind of like NMM or something like that. They've created a network model to be able to describe every object, right? And with that, you can define the topology, right? And I guess for cloud, you may want to go a step above that, right? Because it's not just a network topology with just the nodes and all that stuff, but even at a service level or application level, right? What that would do is that if you had, so for example, when users came to cloud, the first thought we had was, you should know nothing about network, right? And this is still the goal, right? Unachieved, right? And hope someday that a user doesn't need to know that I really need to do NAT, right? Or that I should have packet mirror turned on, and so on and so forth, right? I should just describe my service, right? For example, I should say, these are the servers which need to be able to access the internet, right? And I say, of course, you absolutely do not want to give external IPs to every VM of yours, right? Which unfortunately was our default to start, right? And it comes for a certain reason, right? By having external IPs, we could do a lot of communication while we didn't have through the private, right? So now you kind of take it out. But if the service just said, that's what they describe, I need to be able, this is my flow. These servers access something on the internet, I say I need to do NAT for you. You don't need to define it. So now if you think like this, actually the user, even in the cloud, as they completely bring their workload, their own network, virtual network, is an interesting footprint. It is not as interesting as a diagram I showed you, right? Or even more gorier than that, like our complete B2 network or B4 network, but it's an interesting diagram. Especially if they have on-prem connectivity. Where are their VPN tunnels? Where are their interconnects, right? How much traffic is going where, et cetera, and all. This, if we made again as a standard network model, then as they go multi-cloud, again, they can use it. Or third-party product vendors can do some interesting tools out of it, right? So that's why. That's it.
Okay, thank you, Aspi.
Thank you.
Our next speaker is Patty. Patty Kumrao is a vice president in the data center group and the GM of Ethernet networking division at Intel. She leads the design, development, manufacturing of Intel Ethernet network adapters, controllers, switch silicon, along with next generation solutions used to accelerate networking, storage, and network security in data centers. Kumrao has 2 decades of experience in CPU design and technical leadership. She has led multiple teams developing Intel processors for data center, networking, storage, and autonomous driving applications. Thanks, ma'am.
Thank you. Can you hear me?